So, hello guys. Today we will be talking about FaceNet, the latest model that we have been working on for this week. So, let's just dive right into the code and how the code works and all that. All right. So, first we have a simple import statement which we'll be using to display image on the Google Collaboratory since cv.show does not work due to Jupyter notebook limitations. Then we just have some standard imports here that we do. This is just a simple code so as to connect the drive with the Google Collaboratory that you are using right now. After that, to run this particular version of code, we need a Python module known as Keras FaceNet so that we can directly import the FaceNet architecture and start using it. So I will just run that. Since I have already installed it, it will give me requirement already satisfied. So now the next step is initializing all the environment variables which I do using os.environ and like just a few other standard imports and stuff like that. I also initialize the FaceNet model, that is I just load the architecture, not the weight, using FaceNet equals FaceNet. So what this line of code right here basically does is that it initializes a variable known as FaceNet into which we load the model architecture of uh, from Keras known as FaceNet. So FaceNet is a type of CNN architecture that we use so as to train models and stuff like that. After that, we introduce a confidence threshold. A confidence threshold will be necessary in the later parts of our code so that the code does not give out uh, outputs at a at a low confidence thresholds and stuff like that. So look, going forward you will be able to understand more clearly why it's more important. We have set it at zero point 0.8, that is basically only if the model is more than 80% confident about something will it be giving us the prediction. All right. So after that, the next step is I will loading the face embeddings that will be necessary for using this model. I have just uploaded the necessary files here in the temporary storage for now. When actually in use, we can have it on permanent storage and stuff like that. But basically, this part of code right here that you see, we are using this to load the piece embeddings and the label encoder and stuff like that. All right. After that, we use model equals pickle load, so as to like finally load the model in read and write mode. That's why you're loading it in the RB mode so that we can read as well as write to it. After that, it's very simple what we are going to do. Firstly, we'll be iterating over all the images present in our directory, uh, sample photos week 2 day 1 for the full class. Then using frame equals cv2.imread, that is this line right here, I will be iterating over all the photos present in the set directory. So after loading the said image into the variable frame using cv2.imread, I initialize a function known as face detector. Face detector will be a Dlib face detection function. Dlib is nothing but a face detection library that will provide us with the location of each and every face given an image. So that's what I'm going to do next. So I will just create a variable known as faces. It's going to be a list. Now faces will just store the location of all the actual faces, like that's a named it faces. So faces will be storing the location of all the faces from a given image. So for our case, it is frame is the image that we are providing it. So I will pass frame as the argument. Next step is define the confidence threshold so that the image, like so that the model that you're using does not give prediction for each and every image irrespective of its confidence level. That is basically, even if it's only 20% confidence that a given image belongs to say class 1, then also it will give the prediction as class 1 since it's the class with highest probability. So basically we don't want that, since 20% probability means that basically if the highest probability is 20% means basically that class is not a part of our training data set. So yeah, we don't want that. That's why we set a confidence threshold which says that only give the prediction if you're 80% confidence, otherwise just say you don't know what it is. All right, that's why we are initializing this variable right here, confidence threshold. After that, we make an empty list final names that will be storing the names that are present in the image, the final names that are present in a given image. So the reason that we need to initialize it as empty list in each and every iteration over our over the whole database or over all the images that we have to give prediction on is so that the images from the, like the names from the previous image do not get carried over to the prediction for the next image. That's why we need to initialize it as an empty list each and every time. After that, it's very simple. Now that I have the location of all the faces, I just need to A, extract all the faces, and then B, give a prediction on them. So that's what I'm doing in the code next. So using a simple for loop, I will be iterating over all the faces that are present in my variable faces. So I will be iterating over all the faces that are present in the image that I provided frame as we had named it. We initialize now four variables here: x, y, w, and h. X, y, w, and h will respectively store the leftmost pixel, the bottommost pixel, the width of the image, and the height of the image. So using these four values, we can basically calculate where the face exactly lies, since x comma y will be the location of the bottom left pixel, whereas x plus w and y plus h will be the location of the right top pixel. And my image will obviously be between both of them, so it's just a question of building a square around them. So moving on to the next part. The next part is I initialize a temporary variable known as image to extract my set picture from the frame. So what I'm saying ki I make a variable image from my main image, that's the frame, that's the main image in which the faces are present, cut out from y to y plus h. So basically I'm seeing from the bottom line, that is y, to the top line, which will be y plus h, and from the leftmost limit, that's x, to the rightmost limit, that x plus w. Cut out this part. So this will make it so that each and every phase, for each and every iteration, like obviously since we are iterating over the variable phases, we will be taking one phase at a time. So each phase will one by one be extracted into my variable image. I after that just resize it into a square that is 160 by 160, since it might be having any dimensions, but machine learning models need the images to be like in a standard format, in a fixed dimension. So we'll be just resizing it to 160 to 160. After that, we'll be calculating the embedding or the location of the said image. So I use embedding equals FaceNet.embedding, and then I use FaceNet is equal to model.predict embedding. So basically, what I'm doing using these two lines of code right here is giving the my image to my pre-trained model, and then getting a prediction from it that exactly which class does it belong to. So after getting a prediction using this piece of code that we talked about right here, the we like are not going to use any confidence threshold or anything to pre-process all the predictions or stuff like that, just so as to see what's like the raw output of my model, right? So like this code part of code right now is not useful here, since we won't be using distances or confidence variable at any point here. That's something that we'll be looking at ahead in further part of the code. So I just then append my prediction to my final name that will be storing firstly my prediction, the location of the said face, and what is the confidence with it which my model is giving the prediction. So I will just be storing that to final name, after which I'm just going to iterate over final name and show each and every and show like the image key. What basically I will be putting rectangles around each and every face to show that this image is for boy one, this is for boy two. So I've actually already ran this cell. It took something like 22 seconds, which is really good considering the number of faces I actually had to process. So yeah, this is the output that we will be looking at. So, looking at this, obviously there are many issues that you can see here. Firstly, like we have actually only trained the model on six faces, that is three boys, three girls. So ideally, it should have only detected or given prediction of up to six faces, not more than that. So, for example, this girl is been called girl three. Okay, no issues with that. She might be girl three, but if you look carefully, this girl right here is also been called girl three. So obviously, a single girl cannot be existing at three spaces, right? See, this one, her, she's also been called girl three. This girl is also been called girl three, and so on. So, like as I said, obviously a single girl cannot be present at more than one faces. So that's something that we'll have to look into. So we'll have to implement something that is similar to a set, so that each student only occur once in a given classroom of an image. Other than that, there is also a confidence issue. For example, this girl has been identified as boy one, which is like not possible. But since our model works in such a way so that each and every image has to be assigned a specific class, it tries to assign her any class. So out of all the six classes, it probably had the highest confidence that she's boy one, which might have been a really low confidence, like say 30% or 40%. So even though my code only had like say a confidence level of, as I said, 30 or 40% of this specific girl being boy one, but since it had to compulsorily assign a class to each and every said image, it assigned it a class of boy one. But that is obviously a faulty approach. Other than that, there is also an issue of these one, two, three, four. All four of these girls being assigned the class girl three, which obviously won't be possible. So we will look into using something similar to a set where we will be comparing the confidence values for all the classes if single class happens to occur at multiple locations. For example, these one, two, three, four. All four of these girls are been identified as girl three. So we will just compare that which one of these girls has a higher confidence value. Like for example, this one might have 40%, this one might have 50%, this one might have 60%, but this one might have say like 90%. So obviously, since 90% is the larger values of these four, this girl will be assigned a class girl three, whereas all the other three girls will be assigned a class of none. We will also be introducing a confidence threshold so that cases like this won't happen, where even for a very low confidence value of say like 30 or 40%, it is wrongfully assigning a class just so that each and every image has a class, or each and every face has a class. So that's what we are doing in this part of code right here. Firstly, we will be introducing a confidence threshold. Firstly, we'll be So that's what we are doing in this code right here. So firstly, we will be introducing a confidence threshold of say around 80%. So confidence threshold I am defining here as 80%. So we'll be introducing a confidence threshold of 80%. So what I'm basically saying is that if np.max confidence, that is basically if the confidence for my prediction is more than 80%, only then this part of code will run. So I will just initialize a variable temp and assign it the value 0. Then I will iterate over my final name list to check if my current prediction is present in my class. So what I'm saying is that for a in range length of final name, so I'm using this to iterate using index over my list that has all the classes and the location stored in it, final names. I'm iterating over the whole thing. After that, for each and every location, that is at each and every A0, I check if A0 marks my encoder's output. So basically, I'm saying is it that my class that is present in encoder or inverse transform, that class prediction, is it already present in my final name list? If it's present, I will assign temp a value of 1. After that, I will check that which one has a higher confidence value, my current image or the older one. That is the one that I have detected in my set. So I will just say final name A5, that is A being the location where my name is been again located. So for example, say boy for girl 3, all right. So let's say girl 3. So girl 3 is already there in my final name set. So what I will do is I will A will be representing the entry for girl 3. Phi will be used to select the confidence value. So I will just compare the confidence value for the current person who has been classified as girl 3 and the girl who has already been classified as girl 3. So I will just use a if statement. So obviously, if my current girl has a higher value of confidence, the older girl that is already present in my list final name will have to be replaced. So that's what this code does right here. So at location A, where like the old location of girl 3 was present, I will just again put the class name, which in our case, in our example, will be girl 3, xywh, which is the location of that said phase, that is, it's the location of new girl 3, as well as np.max confidence, which will basically store the confidence for the current prediction. Obviously, if the old entry has a higher confidence threshold than no need to change it or replace it. That's why I'm not using a else statement. So no need for that. So after that, that's what will happen in for loop. For each and every class I will compare and stuff like that. At the end, the for loop will end. If at the for loop end of for loop, if my temp value is still 0, it basically means that the class that has been predicted is not a part of my final names list, so it can be directly added without any comparison. So basically in this for loop, if I do find out that the class that's been predicted is already a part of final list, we will be just doing the comparison thingy and setting temp to 1. So basically I don't need to append it. But if temp still remains 0 by the end of the for loop, it basically means that the class is not present in my final name, so it can be directly added to it. So that's what I'm doing. That if temp is still 0 at the end of the for loop, after the for loop ends, then just append it to final name with all the necessary stuff, that is my prediction, the location, and the confidence value. After that, again I use a for loop to print out stuff. And like compared to before, all right, the predictions and stuff is a lot more accurate. So basically, as you can see in this image, before one, two, three, four. All four of these people were being marked as girl three, whereas only this girl in actuality was girl three, and not obviously all four of them. So she's been marked correctly due to the obvious or the simple fact that since I'm comparing the confidence values for all the four images, since girl three can only exist at one point, using this for loop right here, since we'll be comparing the confidence values for all the four girls. Since she has the highest confidence, she will come out at the top and stay in the final name, whereas all three of them will be assigned a value of none, or basically they won't be stored in final names, or they will be discarded. Similarly, since we are using a confidence threshold, this girl who has before been marked as boy 1 will not be marked as any class at all, because obviously, even though she was been marked as boy 1, it was probably at a really low confidence value of, say, about, as I had said, 30 or 40%. So that's been discarded too. And this actually has a really high accuracy of somewhere around 90%. So it was really necessary for us to implement this small part of code right here. Even though it's a really small part of the code, it's doing a large amount of work, and it's really important to make sure that the case of multiplicity doesn't occur, that a single class has been, or a single student has been said to be occurring at four places, and the code giving outputs even for really low confidence threshold values. So yeah, so that was it for the FaceNet, and that was it for our update. We will just be looking at a special case. This was class 3. So for this class, we had actually trained the model on the faces of all the students present in the said class, and I'm really happy and proud to announce that this model actually had an accuracy of 100%. That is, each and every one of the people that you're seeing in this class has been identified correctly. So thank you guys. This is it for the update for this week. Thank you for tuning in.